Hello and good day to all of you. My name is Kelvin from Cybernet System Malaysia. Welcome to our webinar today entitled Mura Effect Simulation in Backlight Display by Ansys SPEOS. So this will be our agenda for today. First will be an introduction to Cybernet System, Ansys Multiphysics Platform, and Ansys Optical Design Software. The second part will be Ansys SPEOS introduction. The third will be Ansys SPEOS for display application. And finally, the fourth is a summary and Q&A session. Okay, first for the introduction. Cybernet Systems headquarters is located in Japan. We are the Japan's largest CAE software distributor, Tier 1 listed company, and R&D and sales subsidiary all over the world. Out of Japan, we have 4 overseas sales subsidiaries, namely in Korea, China, Taiwan, and Malaysia. We also have 3 software developer companies, namely in Belgium, Canada, and also US. We carry our solutions by Ansys. Ansys covers a wide aspects of simulation throughout a product engineering lifecycle. Today, we will focus in what Ansys offers in optical and photonic solution. For a better understanding, let's segmentize to 3 different approaches. When an engineer is dealing with macro size issues, we have Zemax for imaging optics and SPEOS for illumination optics. Whereas for mesoscopic and micro size issues, numerical will be able to deal with wave and quantum issues. Here, I will show how we can apply Ansys multiphysics integration for a car's heads-up display. Firstly, we can design the HUD's mirror by Zemax freeform design. Windshield polarizer concerns will be handled by numerical microstructure design. And in order to validate the designs, we will import this data into SPEOS where we can do various image analysis. Lightning generates heat and risk of thermal deformation, and we can further couple with fluent and mechanical for thermal analysis. Finally, considering the thermal deformation result, we can import the data back into SPEOS to run the light simulations again. Okay, next, let me introduce you to Ansys SPEOS. Any products that deal with light can use Ansys SPEOS to design. As you can see here, Ansys SPEOS can cover a wide variety of lighting industry such as automotive lighting, general lighting, digital optics, and also display. Automotive lighting design is a highly complex model that consists more components than other electronics. In this case, Ansys SPEOS provides a convenient platform where user can easily model and edit its geometry and further run the lighting simulation. In this video, the left side of the taskbar consists mostly CAD editing functions, and the right side is the SPEOS lighting functions. After complete the design, a user can start to run the simulation and see the result of your design. In some cases where users are worried about their CAD format, you don't have to worry about that because SPEOS covers a wide list of CAD format as you can see in this slide. I believe most of the common CAD that you are using can be imported in as well. Another strength of SPEOS is its built-in CIE international regulations, where SPEOS can help you to validate your design in accordance to the international regulations. Other than that, Ansys also collaborate with major car makers to import the DLL files into SPEOS. Same as above, once the simulation is complete, SPEOS will be able to generate a validation report here, and you can send it to the car maker. Lastly, for automotive lighting application, user will need the visual rendering function. Usually, a user makes a judgment until BSDF level. In SPEOS, you can further enhance by adding texture and bump for a near real vision of the design. With this function, a user can check and confirm the environment of the light condition and minimize glarings. Okay, next we will go to general lighting. There are many general lighting applications that SPEOS can cater. General lighting will require all kinds of receivers, and of course, these receivers are also available in SPEOS. Here are two examples on how SPEOS can be applied. Firstly is the indoor sterilization by invisible light. After creating a 3D model of a room and material setting, you can conduct a UV distribution simulation in the room. The second example is fluid sterilization by coupling SPEOS and fluent. Considering fluid flow in a pipe and setting the light source in SPEOS, user can understand the sterilization effectiveness. Finally is digital optics applications. One of the most common topic is lens stray light. In SPEOS, we can evaluate the image quality of the main sequence. We can also evaluate the final results by all layer. In the case when we can find the stray light, we can go back to each sequence to clarify the light source and the severity of the stray light. SPEOS is also capable of handling LiDAR design process. Depending on the LiDAR solution required, we can couple SPEOS with different products such as ZMax and numerical. Next, let me go into our main topic for today on how Ansys SPEOS can use for display applications. For this section, I will talk about three applications. Firstly, on the application of secondary lens. Second, on the side-in backlight application. And third, on display-related application. The purpose of second lens design is to optimize the LED intensity, thus reducing the number of LED. Here, let me introduce how we can implement the design process through SPEOS. In the first stage, we conduct the intensity analysis on the lens design. Our target will be through Lambertian method to reach the same radiance on the same surface. In the second stage, we can easily import Project A to prepare the CAD array function. After complete simulation, we can directly repair the lens in the SPEOS to optimize the intensity in the third stage. In the final stage, the CAD array will be modified accordingly from the changes in third stage, and we can repeat stage 3 and 4 until reaching to our preferable result. From here, we can see the advantage of SPEOS of handling the full process easily. Apart from this, SPEOS also have an advanced feature called human vision. In the following slides, I will explain of what is the difference it can offer and how it can contribute to a better judgment. Human vision and digital has a very different perception. In the human vision, our eyes send signal to brain to perceive an image. In the other hand, in the digital, the image goes through, for example, a camera lens and displayed through a monitor screen. Thus, the same image but perceived very differently between human vision and digital. The same goes when we do a product design and run the optical simulation. When the simulation result pass through the machine spec measurement, it might be judged okay. But the same judgment doesn't necessarily apply for visual product inspection. So why is that? Actually, there are many differences between human vision and digital. But today, we are going to talk mainly on the main three differences. The firstly will be brightness evaluation. On Earth, our human vision is capable to see the natural brightness of a sunlight and the nighttime starlight. But that is not the case for digital because its range will not be as wide as human vision. The human vision has the capability for dynamic brightness evaluation where digital is a linear type. Let's use these two graphs as a reference. In case of dark tones, our eye's perception of dark tone will be wider compared to the digital, which is a narrow and linear tone. From these two photos, we can see the comparison. In the human vision, we can see outside the window is relatively brighter than inside the room, whereas in the digital, the brightness seems flat. The same goes for the darkness on the right side desk. The problem between these two differences can be solved in SPEOS. Using vision parameters, we can adjust the ambient brightness, time adaptability, and adaptation type. The ambient brightness adjustment is useful when there is a dynamically brightness difference happen, whereas for the time adaptability is useful when to consider the duration for an eye to adjust for sudden brightness change. Next, the biggest difference would be the human eye's retina and digital photosensitive element. Our human eye retina is nonlinear and tends to center focus, whereas the digital approach by color filter arrays. This causes our viewing angle is vertically restricted between 15 degrees. The second point is from the point of individual color sensitive, where human eye is less sensitive to blue compared to green and red, while digital has a more normalized approach. In this photo, we can see the difference when a human eye views the actual product and when viewed through the digital display. In this area, SPEOS is able to set the vision parameters such as age, aperture, focal length, and red-green deficiency. Next, we are able to do a screen calibration where we can simulate the luminance. The last point will be human vision and digital's optical system difference. In the human eye's retina, light travels into the eye and creates scattering. Thus, this will create glaring in our vision. Whereas in digital, optical system is optimized to have a focus-centric light. We can simulate both differences as shown here, taking an example of a car headlamp. As you can see, there are glarings in the human vision, while the lights in digital are clearly defined. In this area, SPEOS is able to set the vision parameter based on the two theories, Voss 1984 and Holliday 1926. So with SPEOS human vision capability, we are able to connect the line from optical simulation result to product visual inspection and further ensure that the actual product lives up to the expectation of product visual inspection. So back to our secondary lens design evaluation with the added human vision capability. We are now able to see the yellow dots as a verification of how it would appear to a human eye. Next, let's see how Ansys SPEOS can support for sight-in backlight application. As most of us may know, there are four main structures for a backlight panel. The side where the LED position will have some serration, bottom side will have dot shape, top side will be lenticular, while CNC polishing as a finishing. Each of them can be considered in details during light simulation with different difficulty and importance in mind. The general design process of a backlight application would consist of CAD modeling, input dot pattern, pattern density optimization, and local optimization. In the next slide, let me show you a short demonstration by using SPEOS. In SPEOS, we have another function, which is the VR 360. This function enables a user to view the product in different angles. For the third and final display application, I will explain by using two examples, namely reflection from mobile phone and curved angle display in a vehicle. Under the sun, glaring and reflection on a mobile phone screen is a common issue. To overcome this issue, we can add an anti-reflection filter in between the front glass and LCD module, which consists of a polarizer and a quarter-wave plate. In SPEOS, we are able to set the parameters in Jones matrix and VSTF function, such as material properties and surface reflection condition. There are more than 2,000 material settings available in the library, and user is also able to customize the new materials. After complete the simulation, we are able to do a reflection and colorimetric analysis on both scenarios. With the readability analysis tool, we can understand the contrast level if it's able to meet the requirement. Another strength of SPEOS is the consideration of human factor in its simulation. In this specific result without filter, the visibility for people over the age of 40 will be poorer, whereas with added filter, the visibility will be extended to 65 years old. The next application will be on curve design setting. In this example, we will be using two functions, the VR360 and natural daylight setting. Earlier, I have demonstrated the VR360 function for viewing different angle. In the natural daylight setting, user is able to set the ambient in accordance to CIE standard. So far, SPEOS is the only software that is certified by CIE. In this car interior example, a user is able to do a virtual inspection under a certain ambient light condition. When a user found a problem such as glaring or reflection on the panel, the user is able to optimize the design within SPEOS environment. Finally, let's have a quick review of today's topic. SPEOS is a powerful optical and machine integration environment which can greatly shorten the product development time and perfectly solve the cross-platform serial connection bug. For example, CAD model missing surface due to different software. The unique human eye simulation and VR360 that makes the simulation close to the real human eye experience while meeting the objective measurement, specs, and subjective visual appearance taste. And finally, SPEOS' maturity in the automotive market and its successful experience in a variety of optical industry are not only a display backlight development tool, but also provide an opportunity to enter multiple fields. Thank you very much for your time. This concludes my presentation today, and next will be our Q&A session.